I just got a text from Big Dave Wave.
This will be a short description of how DSLR cameras work and how to use them in manual mode. And then I'll do a quick overview of how to use Adobe Lightroom with the raw image. I'll go over shutter speed, f-stops, and ISO, and how they're used with the camera's built-in light meter to achieve proper exposure and your desired look. DSLR stands for Digital Single Lens Reflex. Single lens just means you use the same lens to see the subject through the viewfinder as you do to take the picture. The light from the subject, this little cat here, goes through the iris and the lens to a tilted mirror in the camera and is reflected up to the viewfinder. And when you press the shutter button to take a picture, the mirror flips up to allow the light to pass to the shutter, which then opens, allowing the light to hit the sensor. The mirror then flips back down. This is why when you press the shutter button, you see black for a moment through the viewfinder and hear a thunk. The motion of the mirror is where the reflex comes from in single lens reflex. To get a proper exposure in manual mode, you use three things in concert with each other. The iris, which is just like the iris in the eye, is located within the lens. It can be opened all the way to allow a lot of light in, or closed down to allow only a small amount of light in. This opening size is measured in f-stops. The shutter can be opened for a long period of time to allow a lot of light in, or for a very short time to allow a very small amount of light in. This is called shutter speed. And finally, the ISO sets the camera's sensitivity to light. A large ISO makes the camera very sensitive to light, and a small ISO makes it less sensitive to light. The smaller the ISO, the less noise is introduced to the image. The way the camera works is, when you're looking through the viewfinder, the iris is opened all the way so you have enough light to see what you're looking at and to get a good focus. And when you press the shutter button, the iris closes down to where you've set it, then opens back up again. For this reason, the photo you take might not look exactly like you see it through the viewfinder. This has something to do with depth of field, which I'll explain in a moment. You should see a light meter similar to this in the camera's viewfinder. If you don't see the light meter, or shutter speed, f-stop, or ISO settings, your camera should have an info or display button that will bring them up. The light meter works by showing you a line like this one here. If the line's in the middle, you have correct exposure. If it's to the left, the image will be underexposed, and to the right, overexposed. The goal is to set the ISO, f-stop, and shutter speed to get this line in the middle. The first thing you should do is determine what ISO to use. You always want to use the lowest ISO you can for the situation, so the picture will have as little noise as possible. If you're outside on a sunny day, ISO 100 will probably be best. I say probably because there are some circumstances this won't work, which I'll go over. If it's getting dark out or you're inside, you might need an ISO of 400, 800, or even 1600. Very dark situations will require even higher ISOs, but you'll start to really notice noise in the picture at those settings. I'm going to go over some situations using this photo. Actually, this is a couple different pictures I took that I've combined for this example. Let's assume you're outside and it's not extremely bright out and you've chosen an ISO of 200. The next thing you need to do is choose a shutter speed and f-stop. There are a couple ways of doing this. The first is choosing the shutter speed first, then dialing in the f-stop until the bar on the light meter is centered. The shutter speed is usually represented as 1 over a number. So 1/60th means 1/60th of a second. 1/200th means 1/200th of a second, and so on. You can also have shutter speeds of 1 second or higher. Shorter shutter speeds let in less light, and longer shutter speeds let in more light. So a shutter speed of 1/30th will let in exactly twice as much light as a shutter speed of 1/60th. There are a couple things to keep in mind when choosing a shutter speed. One is how much motion is in the image you're capturing. If there's a lot of motion, you'll need a higher shutter speed to freeze the action. This might be 1/100th, or maybe even 1/6000th of a second if you're photographing something moving really fast. Or you might want the subject to show motion blur. In that case, you'd choose a slower shutter speed, maybe 1/30th of a second, or 1/8th of a second. The other thing to keep in mind when choosing a shutter speed is how much camera shake there'll be if you're holding the camera by hand. You'll need a fast enough speed to compensate for the little shaking introduced by your body. The more you're zoomed into a subject, the more these little movements are magnified, so you'll need a faster shutter speed for a longer lens than for a wider angle lens. The general rule is 1 over the lens's focal length. So if you're zoomed in with your lens to 200 millimeters, you should have at least a shutter speed of 1/200th of a second. If your lens has image stabilization, you can probably get away with a slower shutter speed than the rule, and some people can remain more still than others. You might get a good sharp image at 1/100th of a second with a 200 millimeter lens. You'll just have to do some experimenting. So now you have your ISO set and you've chosen a shutter speed. Now you just dial in the f-stop until the bar on the light meter is in the middle, and you'll have the proper exposure. So that was choosing the shutter speed first and dialing in the f-stop. The other method is to choose the f-stop first and dial in the shutter speed. The f-stop number represents how large the hole, also called the aperture, in the iris is. The smaller the f-stop number, the larger the aperture. And the larger the f-stop number, the smaller the aperture. A lens will typically have f-stops from f2, a very large opening, to f32, a very small opening. And different lenses will have different f-stop ranges. So here's an f-stop of 5.6 and an f-stop of 8. These two numbers represent what is called a full stop difference. And that means f5.6 will let in twice as much light as f8. Changing the f-stop not only changes how much light enters the camera, but also how much the background is in focus or not. This is called depth of field. Small f-stops, meaning large apertures, will have the background more out of focus. And large f-stops, meaning small apertures, will have more in-focus backgrounds. So here, with the lens focused on the cat, with an f-stop of 2.8, the background is very out of focus. This is called a small depth of field, or limited depth of field. And here, with an f-stop of 22, the background is much more in focus. This is called a large depth of field. Here's an f-stop of 8 in the middle, with a medium depth of field. You can remember all this by thinking of a pinhole camera. Images from a pinhole camera have just about everything in focus. And this is because the light coming into the camera is from a very tiny hole, a very small aperture, with an f-stop in the several hundreds. These cameras have an extremely large depth of field. When taking pictures with a low f-stop, that is, small depth of field, focus can be tricky, since so little of the image beyond the subject is in focus. Sometimes it makes sense to stop down to a higher f-stop, that is, a smaller aperture, so more of the image is in focus. This can be more forgiving if there's some error in focusing. So, when choosing an f-stop, you have to decide if you want the subject in focus with the background very out of focus, or if you want to see everything in the photo clearly. And you should think about how tricky it might be to focus on the subject. Once you choose the f-stop, just dial in the shutter speed until the bar on the light meter is in the middle. Another thing to keep in mind when dealing with f-stops and depth of field is the focal length of your lens. A longer lens will allow you to achieve a smaller depth of field than a shorter lens. So with the lens at 200 millimeters, you might be able to get the background out of focus like this with an f-stop of 5.6. But if you were using a wider lens, say 50 millimeters, the background might only become this out of focus at f5.6, and you need to open up to a wider aperture to achieve the same amount of blur on the background. So you can see the relationship between shutter speed and f-stop. Here we have a shutter speed of 1/200th and an f-stop of f5.6 for correct exposure. If I change the shutter speed to 1/100th, meaning the shutter is open for twice as long, twice as much light getting in, the image will be overexposed. I can fix this by changing the aperture from f5.6 to f8, a smaller hole and a one-stop difference, meaning half as much light coming in. And once again, the image is properly exposed. But you don't need to know all the math involved. You just need to either set your f-stop and dial in the shutter speed, or set the shutter speed and dial in the f-stop. In some cases, you might have to change the ISO to get the effect you're looking for. Let's say you want to use a fast shutter speed to capture something moving quickly, and you also want a medium depth of field so the background is not completely out of focus, and you have some forgiveness in focusing. Here, the shutter speed is set to 1/2000th of a second. This lets very little light in since the shutter is open for such a short period. So you'd have to open up the aperture all the way to even start to get enough light in for a good exposure. But here, even open all the way to f2, there's still not enough light. Now is when you'd change the ISO. You can experiment by choosing different ISOs until you get the right exposure with this shutter speed. So I've changed the ISO to 1600, and now I can set the f-stop to where I'd like it to be at f5.6. You can bracket your exposure by first getting the correct exposure on the light meter and taking a photo. Then underexpose by going to a faster shutter speed and take the photo. And then go to yet a faster shutter speed and take another photo. Then put the camera back to the correct exposure once again and overexpose by going to a slower shutter speed and taking a photo. Then go to yet a slower shutter speed and take the photo. Now you have 5 images. 1 perfectly exposed according to the light meter, and 2 photos that are underexposed by different amounts, and 2 photos that are overexposed by different amounts. These 5 photos can now be used to make a high dynamic range photo, or HDR. One thing you should do is make sure your camera is recording RAW images along with JPEGs. The RAW image has a lot more information than the JPEG and can be manipulated a lot more. And so in the next section, I'm going to go over using Adobe Lightroom using the RAW image.